Hello, Atul, good evening. How is it going? Yours? You are going?
Awesome.
Okay. You are in office or you reached home?
No. I'm in home.
Oh. So you will handle this workload and that one. Means even you have so many heat exchangers that to complete and you manage within the time that one.
Workflow. I also surprised how can I do how can I doing this. But workflow and our department environment is pretty good. That's why the things are going well.
But your department, means maybe you are senior and sometimes they want to complete this to be completed today or this to be completed this time. They will not used to say this type to you.
Yeah, our working is like our department and marketing department has mutually understanding. If a marketing department got L1 in any order, they told us and we prepared drawings and mechanical design and everything before PO placing. Because PO placed after 7 to 10 days. In between them, in that time we complete our 40% work. That's why we are ahead of the purchase orders and doing well.
But sometimes if yellow, means PO, they said that they will place the PO L1 they given, but after that one they not place the PO. They might be cancelled or
It happens sometimes. But if client does not place the purchase order, it's a practice.
Okay, but it's practice. But you have done almost 40% of work. Then they cancel the work. Then
Yeah. No. We hold it. We hold total work if 40% or 100% is completed. But we do not have any work or we have to do with the same work. Our all work is completed. Our management is also very curious about कि हम क्या और काम दें. That is our design engineering team is have no workload.
But you are alone engineer and handling so many heat exchangers. Still, they are finding difficult to give work to you.
I do approximately 30 heat exchangers for
30 heat exchangers every month or every year?
In total, if we see in a batch, I design 6 heat exchangers.
In 2 months, 30 heat exchangers.
Yeah.
And also their technical documents review. I don't know the now recent engineers.
All documents we reviewed.
Yeah.
Code 1, division 1 and division 2.
You have any issues to discuss?
Right now, I don't have any issues.
Okay, Kaushik, welcome.
Yeah, good evening.
Good evening. Okay, do you have any issues to discuss?
Okay, just I have some drawing question like for this, the tube sheet. The tube sheet, there is a tie rod, right?
Yeah.
Okay. The tie rod, how much it should be inserted?
1.5 times of the dia.
1.5 times of the dia. Okay, so now suppose the tube sheet thickness is 100 mm. Okay. Okay, then the both side there is one is lower RF and is higher RF is there. Means 2 RF is there. Suppose the RF is 5 mm, lower RF, the higher RF is 7 mm. So how much is 12 mm?
Yeah.
Okay. Yeah. So and tube the tie rod diameter is 16 mm.
24 deep is required.
16. Then what I told 7 plus 5, 12 and 16, and that side 100 mm. So now how much it should be inserted?
It is only 24 deep.
If I insert 24, then the thickness of the tube sheet will not be considered 100, right? Because that 12 mm plus 24 minus 16 minus 12 is you're almost 4 mm, and you are telling it is 1.5 times. So 12 mm extra input inserting. And then the thickness of the tube sheet on the calculation should be considered at 100 minus 12, right? Am I right?
Yeah.
So that is not correct, right? I mean to say that way.
Yeah, it's we are using it's the last all projects. We always use 1.5 times, and because we did not do any tie rod calculations in PV light, and we just put it RF with RF depth.
Yeah, that may be I mean to say good engineering practice or the fabrication long time they have did it and it was like strength they are getting. But my query is like, if the thickness is 100 mm and if I put 24 mm, okay, insertion, so 12 mm because of the RF, that I can understand. Now because of this 12 mm of the thickness of the tube sheet gone. So have you found any queries from client, like what should be the thickness, calculative thickness of the tube sheet?
No. We did not find any query from the client end.
Okay. So I mean to say that 1.5 times is this criteria is like standard. There is no
1.5 times is standard for all tapping things like pulling eyebolts. Sometimes pulling eyebolts and tie rod is diagonally opposite to the tube sheet faces. One is cell side and one is tube side. So we change the location of the tie rod or pulling eyebolts.
Okay. Pulling out eye bolt is normally outside that pressure zone, right?
Yeah, outside the pressure zone.
Okay, so then the thickness will not be an impact. I mean to say, if I calculate the thickness of the tube sheet, I should consider which is like in the pressure and temperature zone. You can tell me if I am wrong. I mean to say that way normally do the calculation.
Yeah, because we are calculating only for number of holes.
Yes. Okay. Thank you.
What actually, Kaushik, means you want to tie rod how much it to be inserted in the tube sheet, right?
Yes.
Yeah.
So this if the tube sheet thickness is less, then still
no. My question was like that. See, suppose you now mathematically 100 mm is the tube sheet thickness is required. Okay. Suppose it is required or it is given and it is coming safe in PV light. Okay. Now suppose you want to insert the tie rod. So tie rod OD is 16 mm. Okay, just you are assuming all those parameters.
Okay.
So now 16 mm, if I consider 1.5 times, so it will come 24 mm. Okay. And then the tube sheet, there is extra RF is there, which is not calculated as a thickness of the tube sheet.
Yeah.
Okay. One is the lower RF, one is the higher RF. That is, suppose the higher RF thickness is 7 mm and the lower RF thickness is 5 mm. That is also just I am assuming now.
Okay.
So it will be 12 mm. Now you are drilling the tube sheet. So how much is required? 24. So 12 mm RF you are getting already. Extra 12 mm you are drilling. So that means the calculative thickness of the consideration should be 88 mm. Okay, so you should put in the PB light 88 mm, not 100 mm. But actually nobody put like that. So my just the query which Atul was, okay, is it anybody asked if why how much thickness should be considered? So he said no, 100 mm if I consider it's okay. Nobody asked that question.
Yeah, 100 mm if you consider in the PV light calculation, that's okay. But the tie rod insertion, you want the depth, no? How much depth to be inserted in the tube sheet?
That is, you are reducing the thickness, right? I mean to say in that way.
Yeah, reducing the thickness,
right?
but only to tie that tie rod, right?
Yeah, because your thickness, uniform thickness should be 100 mm. That should not be, I mean to say, in that zone, there should not be any, if you are drilling with the tubes throughout, that is you are already compensating, right? I mean to say that is considered. But now you are in between also, you are drilling for the tie rod. So that thickness reduction of by 12 mm, you are not considering in the calculation. You got my point, right?
Yeah, I got your point. But you mean that if we drill that one and due to that drilling, this tube sheet will fail on that point. You want to say that one?
Yes. And at that point, the thickness should be reduced, right?
Yeah, thickness reduced, but we tied with the tie rod, no? On that place.
But that is, nothing is compensated on that, right?
But compensated means if it's completely...
Does your thread tied that one?
Yeah, but if you completely open, then we compensate, like in nozzles. When we open that part, then we compensate with RF pad. But here we are not opening that one. We're drilling and putting some other material, means tie rod material on the inside in that one.
No, anything actually you are drilling. Suppose you are drilling something which is not compensated. suppose just for example, any vessel, pressure vessel, okay. So normally pressure vessels, there are so many nozzles, right?
Yeah.
All nozzles are compensated either by providing RF pad, or you are making a high thickness nozzle, so that you are compensated. Now suppose you need a drilling for thermocouple, okay, only a drill. I mean to say, you want to drill it, maybe 50 out of 100 mm, you are drilling 50 mm, but you are putting the thermocouple there, okay. But then also, then there is a question asked: if I am drilling, then that thickness is reducing, right? But for that's in the ASME, there is a provision. Okay, if for the pressure vessel, I am not talking about now tube sheet. For pressure vessel, there is a thermocouple. There is one clause, appendix is there. If there is a requirement of thermocouple drilling, then how much you should drill. Okay. But for tube sheet, nothing like that. So that's why I'm asking, if the thickness is reduced, suppose how much I should drill, that anything is written like, okay, this much only you can drill.
I think
only the tie rods.
Yeah, I think it's not written like that, because we are not removing, we are removing material, but we are adding with tie rod. But in other nozzles and other cases, we are completely removing that material. There is nothing is there in the nozzle inside. If you see the nozzle inside, it's open.
Yeah, but in the low pressure part.
Yeah, you can say in that way, you are removing the material.
Yeah.
Okay, but that whatever you are putting, that is not. You cannot say it's a. How you can say that it's not a constructed part. You are just threading it.
Threading.
Got my point.
Yeah, threading plus we are putting something else.
This threading part, we cannot take any load.
Threading parts, but it's completely packed, no? In that this tie rod
not that way. You just think in that way. Like pressure is uniformly distributed on that, right? So that part will be the weakest part, right? Because there are so many. If you consider a uniform tube sheet, and there is a one part, there is a drilling. That means that is the weakest part. You just consider in that way. It's the weakest part.
Yeah, if you drill and if you left, then that is the weakest part. If you drill and if you are putting some other material in that one, then that is not. That is become again a one like welding. When we do the welding,
that is also weakest part. Weakest part until unless you close it by welding.
Yeah.
I mean to say the fusion.
But close by welding or close by threading also it's same. We are tie rod are threaded, and it's threading. We are closing that hole.
Yeah. So
but that is semi-permanent joint. Welding is permanent joint, but threading is semi-permanent.
Yeah, semi-permanent. Whenever you require, you can open that one. That's why.
But sometimes we use tie rod as a degraded material from the tube sheet, but we are not providing any reinforcement.
Yeah, but that if you open completely, then you have to provide some. Means my understanding is that one. If you are not you are opening and you are again putting some other material, maybe not the same the material of that tube sheet. Maybe some other material, tie rod material may be different. But again, you are compensating that you have to with that hole. You are closing that hole with some other material.
Yeah, it's a loop. It does not even any return, but it's a practice.
Yeah, we also do the same thing because we are not considered that is the weakest part or any verification for that.
Same as in vessel descent, we use patch vessel descent.
Vessel descent, okay.
Vessel descent for forming, we use patch for the center hole because place machine does not have any option to hold it. So we have to mark a circle on the center of the plate, then we form it. And we did it in 27 heat exchangers. Why did you not ask first us? How can you do it without knowing us? And we putting this as a fabrication method. We can do anything. We can't go for always for approval. And he understood that, and he gave us go ahead.
So if there is no option, then we have to do that one, welding and that one in that you can patch and that one. But here actually Kaushik is asking, he is also, it's a good point, because we are not filling with the same material in that one. Maybe that is the weakest, or maybe if lower material, if you fill lower strength material, then it may be cause weakest part of that one. Okay, Kaushik, I think you have to raise this, maybe the TPA person or maybe some others to check maybe some other insights.
sometimes this question comes from the end user. They are asking. They are not closing it. They are like it's an open point. So that's why
You can
I
tell
just
them
asked
that
this
we are
question.
not completely removing material. We are removing and we are again closing with some other material. But if still you want some other guidance, there is no guidance given for in ASME or something, TIMA or somewhere. Okay, last time I think you are asking something about this. You are asking that different types of tanks and that one, no? Did you find?
Yeah.
Did you see that video that what we are posted related to tanks and that one?
Yeah, I saw the pictures.
Okay. So it's now clear to you?
Yeah, means you can say, see, this is like until unless I do some deep diving,
Uh-huh.
it will not be that easy for me. But yeah, it will be like, see, as we our means organization is doing this automation, right? So we are going one equipment by another equipment. So that is like in our list. Okay, to do list like we want to do automation on the tanks. So that way we have to go some deeper dive. I mean, so when you see the deeper dive means you have to see how many types, okay, and how the construction changes, and all the construction types can we make it in that way. So every change of construction also it can consider.
Yeah.
The model can be generated. So in that way we have to think, not like the project, or you can say calculation wise, but we are just thinking about the construction wise, how it changes and all the behavior can you put it in the automation or not.
Okay. So now, which are in your to-do list now? Which are the equipments?
No, actually we are doing lots of things. So it's not only the as I told you, right? For the heat exchangers, very soon we are going to release some automation mechanism and the in the same way, like there are so many things we are all the static equipments whatever is in the market. So we are trying to analyze what is the market value of that. Okay, so suppose there are so many boilers in the market now, so then we'll think, okay, this is, but as I said earlier also, see, when we consider a vessels, pressure vessels, and the category as I'm telling, heat exchangers having the least drawings produced. Okay. Then we will quote the pressure vessels, because pressure vessels again having the structure. Okay, so the structure supports will come, piping supports will come. So those are like, though the drawing numbers will not increase drastically, but there will be some changes, because the piping supports will be decided by the piping engineer normally.
Yeah.
So there are so many types of support. The same way now, if you go tanks, tanks is more than the tanks drawings are more than the pressure vessels.
Yeah.
Okay. Suppose not marginally very big, but a bit. Means now if you go to the boilers, it's now for just give you a comparison. Suppose a heat exchanger having 7 drawings. Okay. A boiler having 150 drawings.
Oh, that much? It's 10 times. Oh.
Okay, so now 150 drawings, you just understand the how much impact will come for this.
Yeah.
So that way, so our priority is like in that way we'll go. Like we will try to cover all the types, but depends like who are going to invest on us. Okay.
So now you are concentrating on heat exchangers, right?
Yes.
Okay. I think Ammar Bugadi, I think new person. Ammar Bugadi, you are on the mute.
Hello, yes, sir.
Yeah. Can you please introduce yourself? You are coming first time?
My full name is Amar. I have around 4 years of experience in static field.
Okay. So how was?
Right now, it's very fantastic, really good.
Very good. No? Okay, Amar. Did you see in our videos, or you are coming first time to this our discussion, no?
Yes, I am first time.
Did you see in our previous recorded videos or something on how we are discussing that one?
Actually, very few. I think.
Okay. Normally, in what your weeks or recently what you have faced in our profession, we discuss some issues of that one. So just now we discussed about one of the heat exchanger tie rod tying and that one to the tube sheet and that one. Did you come across any issues in recently? Anything you want to discuss here?
Actually, I have come across the heat exchanger stack module. Stack exchanger module, we design stack exchanger module for 2 or 3 stack shells. In that, actually what practice do all follows is I have observed someone has different and some others have follow some different. We actually do put weight of top exchanger on the bottom exchanger and we do apply reactions. But recently we have a comment from client that he is asking to add a cross section area of shells. Is it required when we are applying reaction forces, which is longitudinal transfers?
Your question is that the stacked heat exchanger, in that one you want to apply cross section forces, right?
Yes.
But cross section forces will come.
If we design single exchangers, that is top exchangers at that certain level with given wind and seismic parameters, then we able to get the reactions, longitudinal and transverse reactions at the saddle, and that we can convert with the effective height of top exchangers to apply reaction on bottom exchanger to check saddle of bottom exchanger.
What do you want to answer this?
Yeah, I do approximately 20 to 25 stack units for all types of tumor type. Generally, there is 3 and 4 types of practice for doing stack design. I never use reactions of upcoming in saddles. I have only 2 things. I have to transfer wind and seismic. For if I design top heat exchanger and I got center of gravity and weight and all operating condition, empty condition and hydro condition. Yes. I just have to enter weight only the center of gravity of the top heat exchanger, not on the top of the saddle of the top of the saddle. The correct way is you should design it and add area in all weights. That's area client was commenting on your drawings. And seismic, this is a seismic, and one you have to do pull out test also for
yes,
it. There is nothing else. And there is another practice for stack unit. You can use a wind multiplier. Okay. We generally use 1.4, and you can do it for 2.8. Double it, just nothing else. For wind, you can do it if you want to decrease the wind load, because sometimes if you use wind area as a input method, your load will use, your saddle will fail, your saddle unity will fail. You can do these things also. If you want to decrease the load, increase the wind multiplier instead of added the wind area.
Okay, but can you sir elaborate how wind multiplier affect? That is, how much ratio?
Yeah, in good engineering practice, we will also mention 1.4. It is the normal. If you design your bottom heat exchanger in double wind multiplier, your top heat exchanger will not damage. This is the practice.
Actually, Amar, what your client commented on your this document, design document?
Commented to add cross section area.
But cross section area and weight are 2 different things. So why you want to add cross section area in that one?
He stated if we add area, then whatever the wind effect will be taken care by the area, and the load will.
That's the area only. Section area client will not comment. Is the communication error between client and comment.
Yeah, just as Atul said that you inform him that this cross section area, adding that one, we are multiplying this wind load. The multiplier, wind load multiplier. So in that one, as he said, instead of 1.4, you can take 2.8, means double the whatever multiplier. So if you apply that one, the cross section area almost it's the whatever required it become double.
Yeah, right. And your wind load also comes less as compared to the added in the wind area, and your saddle will fail due to the high load. And sometimes you have to increase cell thickness also.
Here we have practice that we transfer longitudinal and transverse movement from top to bottom.
Top to bottom, again, the transferring, as he said, it's not required. Just taking the loads, weight of that top one, you can consider that one. So how you will transfer that one? You will consider moments and this one?
we got longitudinal and transverse forces from top exchanger summary that we multiply by the height, equivalent height, that is ratio of bottom base to top center divide by bottom base to bottom center.
Yeah, it's an old practice, sir. We skipped it right now.
Okay.
It's the Excel equation.
Yes, yes.
So you also used to do, Atul, right? This one.
Yeah, I also used to do, but long practice and you have to develop new methods, and they guided us and we did it.
So
Actually, this method requires very high thicknesses.
Yeah. This method requires very high thickness. I faced it.
So new method means adding the wind multiplier, right?
Yeah, no. If you want to come come less wind load, so wind multiplier. But sometimes client does not agree. Client, if his piping is failing, sometimes piping engineer does not want to change his pipeline. Then he advised to use wind multiplier only this condition, but use wind area because it's the worst condition.
So rather than considering this weight and that one, better to consider wind multiplier. So you'll get the worst condition to be verified, right?
Yeah. For revision zero, we always submit a wind multiplier, and 8 out of 10 is accepted.
Okay, Amar. I think you also try with this one, wind multiplier. Yeah, you can inform him that saying that it will be multiplies the area whatever the consider at the bottom.
Okay.
Because as Amar was saying, Excel method, we have to put it all loaded on the top of the saddle, both saddle of, and this is a wrong practice because we have to highlight PV light to where is the center of gravity of the top heat exchanger, in which he can do proper calculation.
Okay. The total mass will act on 1 point.
Yeah, 1 point.
So how you will guide to PVL at that CG?
First we design top heat exchanger, we get to the CG of the top heat exchanger.
Okay.
And then we design the bottom heat exchanger. We add that center of gravity of the top of the bottom exchanger. Then our bottom heat exchanger knows that there is something is above me and it has a center of gravity. Total weight is that.
So first you will do the top one, then that what your CG comes, then that you'll apply on the bottom.
And there is one more thing I use, and I do it in engineering. I can design all geometry, another geometry for top heat exchanger, and another saddle geometry for bottom heat exchanger. For base plate, ribs, saddle, I different from top and bottom. If my top heat exchanger passing with less thickness, I pass it. If my bottom is bottom required minor changes, I changes. But sometimes the vendor practices, they change both top and bottom both.
They want to keep maybe same thickness on top and bottom.
Yeah. But I don't do that because I am detailing different.
Mm-hmm.
If my top heat exchanger base plate is 12 mm, I use 12 mm. Bottom is 20 mm, 20 mm, not 20.
For them, maybe they verification they want to keep the worst one 20. If they keep that will be better. But in your manufacturing, the cost will be rises if they keep the both the same.
Yeah.
You got your answer?
Yes, I got it. I'll try this option also.
Yeah, just inform him that just wind multiplier in the area of whatever you require. He said to increase the cross section area. No? Just wind multiply. If you use that one, it will be verified with worst condition.
And as Atul sir mentioned, how Atul sir you do pull out case?
For pull out case, there is only equation F into force into displacement, force into length. Force into length is equal to force into length. And use impact factor of the impact factor. Or sometimes you can skip the impact factor because sometimes you cannot pull out both bundles same time.
Yes, correct. One at a time.
Yeah, one at a time. So you have to check the pull out for the bottom one, just putting the load in the force and moment sector.
Okay. For top exchanger,
pull out force is the heaviest and it will operating load for your saddle designing.
Not operating empty load.
Yeah, empty load. It will play a major role for saddle designing because it's quite higher for all of our loads.
It will impact a higher longitudinal forces.
Yeah.
Moment.
I only pull out for bottom because if my bottom can pull out, everything will pull out.
Okay, so bottom if you pull out at a time you will not pull out both, no? You pull out one. So bottom when you pull out,
pull out.
Yeah. On top top heat exchanger, that the bundle will be still inside. So it will be
bundle.
yeah. So it will be still the loads are means it will holds that bottom heat exchanger, no, still
Yeah, that's why we transfer the
seismic on that time.
weight of the equipment to the bottom.
Okay, but pull out you will verify for bottom or you will verify for top. Which one you will do? Worst condition.
For pull out, I will check for the top.
Okay, top.
Because
That's
for the top, the length of the center to center is center to the bottom of earth is quite high.
Yeah,
and
yeah,
your
that's-
force will become high.
yeah.
If your top bundle is pulling out easily, your bottom and single is will pull out easily.
Yeah.
And sometimes I don't use impact factor about the TAT. Sometimes clients suggest me you have to take in care 1.5 times, 1.5 times, 2 times.
Mm-hmm.
But if two clients I have discussed, can I skip the impact factor? They said, yeah, you can skip the impact factor because at a time only one two bundle will pull out.
Keeping impact factor will be safer if there is
it will be safer.
jam anything. If sudden force applied by puller, then it should not happen.
Yeah, it will not happen because my whole equipment is designing in the 3.5 safety factor. Na?
Yes,
What will
yes,
happen?
Whole equipment is laying, but whatever we consider for this pulling out on that time that load to be taken care. That's why we used to keep that 1 point in even in lifting lug, and that one we used to put 1.5 or 2 times that one. So if something may happen, so that that's why I used to keep this safety factor in that one.
Yeah, sir, everything will happen and sometimes, but we also take a bundle load is quite high now. Take the roundup is 20 to 200 and 300 to the kgs above.
Means you already increases the what your weight you evaluated by PV light and that one. You will add some additional weight in that one.
In PV light, if my two bundle weight is coming 70 to 100, I will take it as the 8,000 kgs.
Oh, okay. So you'll already add the additional that safety factor in that one.
Yeah.
Okay, Amar. So it will be first you have to verify with the top one. It's with the worst condition. So it will be pull out condition. Yes. That okay. Anything more, Amar? Do you have any more issues to discuss?
No, sir. Actually, what I was put in group regarding the fasteners, the client has listed that M60 and material is SA320L7 M material. Actually, the client has calculated the manual root area, I believe. We have put a query for this.
L7 is, I think, earliest material for low temperature.
Yes, low temperature. MDMT is minus 48 degrees Celsius for exchanger. But anyway, 193 also can be used, grade B7M.
So client come back with your suggestion that one? What you are using?
Not right now. We are awaiting client response.
Okay. So as client said that go with that higher size, but that higher size is not available in the list, no? The TEMA list. Okay.
That size is not.
Yeah.
Is there any chance that we could possibly do? It will be like under custom fastener, and using allowable which are provided up to 65 mm.
Yeah, but then you have to give the order and then you have to build that one again. This
How to put all the mechanical properties.
Mechanical properties again you are selecting at the initial stage only. When you select some material for that one, these mechanical properties are assigned.
That properties I will have to provide while procuring.
Properties, no, you have to inform this material we are going to use for your bolt, and accordingly they will do that one. But again, the custom build one, you have to bring their certificates for their material purchase and that one. Everything you have to you have to follow that. Whether it will be passed, then again your EI should approve that one.
I think the client has provided on material on the data sheet this material because it is come with the impact tested.
Yeah, minus 14. It's impact tested.
Yeah, but P7 have an exemption from minus 48.
Yes.
But why it is not available that higher size? Can you do you know any idea about that one?
No, sir. Why it is not available?
Okay, maybe it's not used or not.
Yeah, that's why.
Yeah. maybe it's that higher size is not
Go to
used
that
much.
standard.
Yeah, much standard. So I
Yeah,
think
if someone have,
yeah.
yeah, if someone have, they will charge costly, and that's why management said purchase inside, they are not getting it.
Okay, Amar, just check with client. This is not available in Tima. Better not to go with which is not available in Tima. If you go with not available in Tima, then again you have to pay. I mean, your company should pay with additional charges, and that one approval of material, approval of these certificates, these additional many things will. Okay. So just inform client. We can go with the lower one, or maybe the other material which is available like that. You can try.
Yeah, correct. Yeah.
Okay.
Yeah, if this mechanical design is under your scope,
Yes, in our scope.
then you have to verify the mechanical design also for flanges joints.
Yeah.
Yeah. Then did you verify that one mechanical design?
Mechanical design, I have verified. Actually, what I need to do, increase BCD, and that asks me to increase flange thickness. Whatever client has given is not passing in design. And
Okay.
if I reduce BCD to pass in lower thickness, then the bolt area is coming in picture.
Then how the client is verified given the sizes? Because he's given the sizes means he might be done some calculations on.
Yes, we might have done.
Yeah. So just verify or inform, share with your calculation to him that you whatever you selected that not matching with this bolt circle area and that one.
My proposal option also I will put in his end.
Yeah, yeah. Just inform him that. So any alternate way also we can do with the different grade material and that one. Like that.
Yeah.
But engaging the PCD is not a good thing.
Which is not good thing.
Engaging the PCD, it will make your flange thickness higher.
Yeah, yeah. The flange thickness if you make higher, then the cost also increases. No?
Yeah. Forging will be costly.
Increasing the thickness, you can choose. You can increase the G1 value.
Okay.
Okay, G1 value in a area of that one, right? Okay.
Yeah, yeah.
Okay, I'm gonna try different ways and involve client also in your different way. Yeah, approach him also. So, what your suitable way you can. Okay, Aman, got?
Okay.
Okay. Any more?
Nothing from my side.
Okay, Kaushik or Atul, do you have any more?
No, I have no any question.